It was a great secondary benefit that there are ways of letting this technology have the impact that it can have in this sector that sort of bypass a lot of the obstacles that we saw in the urban air mobility space. We really wanted to get out something that had some meat on it that could lay out the business case for this type of operation, explain how it can work.
Yeah, I mean, we have been talking about this use case for since we started this podcast, and as you know, it's very close to my heart. And hey, welcome to the Air Mobility Show with Amad Malik and my co-host Nadia. Hey Nadia, how are you doing?
Hi, Amad. Doing great. How about yourself?
Yeah, not too bad. The weather has been really bad in Spain, but it's now starting to open up. I think the same in UK, right?
No, surprisingly, it was a fantastic day today. Very sunny for the first time, I would say. But I think one of the highlights of today was that we are having an exciting conversation. In preparation for this meeting under the sun, I was having my coffee and thinking about how many lives could have been saved with the use of technology, where in the world where every second counts and people are dying in remote areas just because a doctor couldn't get to them or because, uh, you know, it's been too long since the emergency services have been called in. Let's hope that the technology that is emerging will progress further so that we are one step closer to implementing the eVTOLs for the medical case. So
Yeah, I mean, we have been talking about this use case for since we started this podcast, and as it's very close to my heart. And I lost my sister because emergency services couldn't reach hospital in time, and I think out of all the use cases, and we've been talking about eVTOLs and broader advanced air mobility, advancement in aviation, electrification, and all the topics around that. And I think the best use case is emergency services. And I thought, one of the best people that I could find on my overall LinkedIn connections was Carl. Carl is an aviation industry expert who has started this new startup, which is focusing primarily on first response and emergency services. And the company is called Jump Aero, which is a very good sort of design. I really like the design. So let's bring in Carl. Hi, Carl. How are you doing?
Hey, great to be here. Really excited to share a little bit more about what we're doing at Jump Aero and the impact that we think that it has the potential to have all around the world. So,
Yeah, no, I
excited
was
for the
very
conversation.
excited to see the design and all the things that you have been doing. And I also was reading into the paper that you also released, and some other bits and pieces and the articles. But first thing I wanted to start with is a little bit of your background.
Sure, yeah. So, like many people in the aviation world, I was fascinated with airplanes from the time that I was a kid. I was reading everything that I could get my hands on regarding the design of aircraft, design, build, and crashed my first remote controlled planes in high school. Um, Went on to MIT to study aerospace engineering. I wound up staying in the aeroastro department there for 11 years, picking up my bachelor's, master's, and PhD on the way, and then founded a company called Terrafugia in 2006. Terrafugia's goal was to try to make general aviation more widely accessible to the broader population by addressing some of the largest obstacles to the more widespread use of general aviation. And basically, we were one of the first companies out there that was really making a flying car, quote unquote, a vehicle that could fly and drive. And in 2017, we were acquired by the Zhejiang Geely Holding Group, which is the parent company of Volvo, Lotus, Polestar brands, many other global brands all around the world. By that time, by 2017, we had become involved in a lot of these emerging eVTOL concepts, electric vertical takeoff and landing aircraft concepts. And that brought us to the use case that many companies are pursuing right now, which is the air taxi use case. I became convinced that, yes, there's definitely something here. There's an opportunity here, but unless you are a very well-funded company, this is not a high rate of return opportunity. This is a long so this is one where it wasn't a great avenue for startups, but around that time in 2019, I started to see there is an opportunity for this technology to have an impact in other areas outside of the highly publicized urban air mobility market that, in my view, were both more impactful to society at large and also had a potential higher rate of return on investment. And that was this use case of eVTOL aircraft for emergency response. And one of the reasons that I was drawn to it was, first of all, it was saving lives with the technology, which, as an aerospace engineer, usually we're talking about, moving people and goods around, or, saving a little bit of time or a little bit of money or what have you. And the idea of saving lives was something that really was attractive to me, for dedicating what I see as, when you're doing an aircraft development program, it's a decade long program, right? So if you're going to spend a decade of your life doing something, it should be something that is going to be motivating you for a long time and inspiring you and your team for the long haul, beyond anything that's just cool or fun or what have you. It's something that is, I think a lot of us who are working here see it as a higher calling, and so that's inspirational and keeps us going. And also, it was a great secondary benefit that there are ways of letting this technology have the impact that it can have in this sector that sort of bypass a lot of the obstacles that we saw in the urban air mobility space.
Yeah.
And that was also very attractive to the entrepreneur in me. That was like, oh, wow, if we can get around this long pole in the tent of, oh, I need a Part 135 certificate, I need a type certificate for the aircraft, I need all of this stuff. I'm a level 2 aircraft from a cert perspective. All of these bigger barriers. And then it's going to be a bit of a political football to deploy the technology, because you're going to have folks that just don't want aircraft flying over their heads. They're like, wow, this is not for me. This is a thing for rich people, blah, 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 blah. This use case bypasses all of that. And so to me, that was really exciting also, is that this is something where, no matter who you talk to, people say, yeah, this is a good use of this technology.
And especially, in this environment right now, and you probably obviously very well aware, the conversations that are going on with all the investments that's been made in the industry. I think we've gone above 15 billion overall. That is, that we know of, and the outcomes are going to be difficult. But this is one aspect of the application which definitely should not meet with a lot of resistance. So I think that's a very good, and kudos to you. I mean, picking up on that in 2019, before everyone started to realize that they've been wasting their money on, well, not wasting, but at least it's been overspent, right? So with the Jump Aero design, and I just want to go back to the paper that you guys published. Can you do a quick sort of brief of what was the purpose and what was the impact after that paper? That was very interesting read, by the way.
What we wanted to do with this paper was lay out a new concept of operations of an aircraft, really, something that is not done today, that is truly enabled by an all-electric vertical takeoff and landing small aircraft that can dash at very high speeds. This emergency first response use case. And it is very different and very unique. And lots of people that are in the helicopter air ambulance business right now see a graphic of our vehicle and think, oh, this is crazy, or it's just some drone guys that don't know what they're doing. But we really wanted to get out something that had some meat on it, that could lay out the business case for this type of operation, explain how it can work with the reality of battery technology today, right? And get out our baseline model of the underlying economics and how this can be a sustainable, actually potentially high margin operation that's the whole package, right? And that's what we were really excited about. Beyond the humanitarian, do good, save lives, all that sort of stuff, is the dollars and cents of it. Because in the end, any new aircraft program is going to take a long time and take a lot of money. And so you better make sure that it's a solid investment opportunity, really, because as we've seen in the advanced air mobility space, there are a lot of cases where uh, it potentially less than ideal concepts have been funded, and then they wind up tanking. And after many hundreds of millions or billions of dollars are invested, and all of that contributed to Jump Aero's publication of this white paper. We lay out, hey, if you are somebody that's looking at these new technology aircraft and you want to be investing in a potentially high margin use case where you can get incredibly high return on assets, higher than any airline industry, by the way. Like it's like the return on assets from this business model are potentially way more attractive than anything else that I've seen in aviation, which was really exciting. Like that was like, you don't get this sort of margin potential anywhere else that I've seen from it. And I'm so we wanted to get basically put that out there and say, hey, look, from our perspective, this looks really attractive, and that's why we're investing in it. But it is very different than what anybody does now. So you have to get it out there. Lots of people have to, throw stones at it, and that's
Yeah,
good. It's a healthy process.
you have to go through a lot of natural selection, right?
Yeah, yeah,
Yeah,
refinement of
the
that.
design, you've gone for a very, and I know that people think, what the hell is it, because it's not a known kind of thing, but from my point of view, that's a very clever design, especially when you talk about jump and go, and you have the ability to go really fast. So how did that idea came about and evolved? Very interesting design, honestly.
Yeah, so I have to give a lot of credit to my team and to our customers. So we had in 2019, when we started looking at this business case, one of our company's advisors connected me to Jacob Reese, who's the CEO of Falck. Falck is a global ambulance and emergency response company. They do 9.4 million EMS operations every year. They work in 24 different countries. They're huge, right? And they know what they're doing when it comes to emergency response. So getting connected at the earliest stages with that level of expertise was really key in helping us refine the design requirements for the aircraft, right? So doing the back and forth and refining the requirements so that we know that we're targeting the right thing, that's going to have the right payload capability, that that we're optimizing for the right metrics that will drive the business economics. Those were all really key. So we had a lot of really good back and forth with their team in the early years, where we brought kind of the tech expertise on eVTOL development, and they brought, well, here's what we would like to have, here's the equipment that we would like to be able to carry, and here's what's really important. Hey, we've got a lot of contracts where we need to be on scene in 8 minutes or less, right? That sort of thing. So that was an extensive process that and we're fairly far along in that now, that we're building our first full scale prototype. But we've flown 4 generations of subscale aircraft, and we have 19 major design iterations. So it's a process, as you know, to mature a concept. But the most important thing is that you get the requirements right early
Yeah,
on, and that they don't change,
yeah,
because every time those requirements change, you incur
yeah,
huge costs.
yeah.
So,
So the departure from the norm. I mean, this is what your design. It comes to my mind first of all, is, and I'm really curious to what is the first feedback or response or reaction you may, if you may, you get from people who've never seen a design like this. What's your experience? What do you see?
um, most people think, oh, it looks like a large drone, that should be pretty easy to make, or that looks like something out of Star Wars,
Yeah,
that doesn't look real.
X-wing reminiscent.
And no one.
It doesn't look like
Yeah.
it looks like you guys don't know what you're doing, right? Like we get one of those too.
Yeah.
Either it'll be easy, it's just a big drone, or the other extreme of like, oh no, these guys have no clue what they're doing. So those are the usual quick, uh, quick
But
reactions to
no,
it.
I mean, I saw your design a few months ago, before, Ahmad introduced that you will be on the podcast. And I sent it to my friend who is a drone expert, and we talked about the concept, and he said this is a pretty cool concept that he believes is right, just due to technical reasons and the payload reasons. But normally, Ahmad is the one who asks all the techie questions. But I wanted to ask you to share more about the technical specifications of your eVTOL, and
Sure.
also to
Mhm.
kind of mention the requirements on the ground, where it can land and where it cannot land, and things like this. Because in emergency situation, things can get quite difficult. So.
Sure, sure. So actually, I have a little model of the aircraft here, for convenience. So this is basically what the aircraft looks like. It has a lot of very unique characteristics, as you can tell. First off, we're starting with 8 propulsors, and I don't have the propellers on this little model, but they are. It is relatively low disk loading compared to the ducted fan concepts out there. Comparable disk loading to what you would have in a Joby aircraft, or maybe a little bit higher than Joby, but not too much. We're in that ballpark. That's a pretty nice spot to be in, for a variety of reasons. The aircraft itself accommodates one person who's a pilot and paramedic. There is a door on the back side of the aircraft, a hatch that opens up. They get in and they strap themselves in onto a bench, and they're basically in a mostly standing position. They're standing with their knees a little bit forward, uh, legs bent, strapped to a bench. The aircraft takes off like this. It accelerates like this. It accelerates and tips sideways. And now the aircraft is configured for high speed
Mhm.
cruise dash. It has a very low frontal area, as you can see. So it really is a dash optimized aircraft. All of the batteries are in these inner pods on either side of the wing. There are 8 individual batteries, 8 individual motors. It's all designed around safety. In the event of a thermal runaway, they vent right to the free stream. You don't have to worry about having batteries venting inside your aircraft. They're very much on the outside of the aircraft if that were to ever happen. It's a very robust architecture. The aircraft has control surfaces as well.
Mhm.
It is actively stabilized. It's actually,
Hmm.
from a pure aero perspective, it's a neutrally stable aircraft. And Ahmad, remind me, are you a aero engineer, or
Yeah,
you
I'm a pilot.
or,
I did some engineering back in the day. Yes.
and Nadia, are you an engineer as well? We can go as deep as you want on the technical side. I don't know how deep you want me to
I'm
go,
not
but
an
it's
engineer. I studied air transport
Yeah.
management, so I'm more of like how airlines make money, and I'll ask you about
okay.
that a bit later. But I think
Yeah.
our viewers would be very much interested in your technology. So please carry on.
Sure. So
Yeah, we do
so
get to a little bit technical, so go ahead, please.
So the big thing about this is the high speed dash capability. The propulsors on it are actually variable pitch. They're not fixed pitch. If you're fixed pitch, you're generally very either incredibly inefficient in hover, or you can't go fast enough. So we do have effectively collective pitch on all of the propulsors. Also, that allows us to do more aggressive maneuvering because we don't need to do RPM control of the props. We can do pitch control and torque control of the motors. So um, yeah, very, very efficient. The aircraft, as I said, will do about 250 knots dash speed. So we're hands down the fastest eVTOL out there. And the reason
And
for
what
all
speed do
this,
you
I
need to
mean,
get to before you can transition? Just out of curiosity.
well, the transition happens gradually over over a range of speed, but the
Hmm.
stall speed of the aircraft is at like up close to 90 knots, in the range of 90
That's
to
not too bad.
200. So
Yeah.
like you're going fast. Okay, so this
Hmm.
is this is a high wing loading aircraft, and the reason is that you need to, the whole economic argument for this aircraft is very different than the economic argument for an urban air mobility air taxi. Um, for those, you're really optimizing for dollars per passenger mile. It's very much like an airline, uh, and you will be driven to a slower speed eVTOL, because that's where the economics will drive you. For this use case, the economics are driven in a completely different way. It's not dollars per passenger mile that's the figure of merit that you're trying to optimize. For this, we're trying to optimize basically how far can you go in 8 minutes. So your 8 minute operational radius. Uh, that was the figure of merit that we were trying to optimize for, because what that translates to is your coverage area, your time critical coverage area. The
Time
farther I can
criticality,
go in eight
absolutely. Yeah.
minutes, the more lives I can save with one aircraft and one pilot, right? That's really what it comes down to. That's the underlying, like the aircraft and the people who are on duty to service that aircraft. Those are the underlying cost drivers, right, of the business model. And so then how many people can you cover with that one aircraft? That's the other piece, which is basically how big is your range? How big is that 8 minute operational radius? Right. So those are the fundamental drivers of the economics of the operation. Very different than any other uh, eVTOL out there.
Because obviously, you're responding to a situation where time is critical. Because if it's a heart attack or a heart failure or something like that, time is really, really critical. Whereas a normal emergency and normal ambulance can reach, it's not a problem. So yeah, I can understand the use case, definitely.
One of the other really interesting things about this concept of operations is that these are one-way missions. These are not you're not going out, you're not transporting a patient. It's not a 135
Yes, yes,
operation,
yes.
and you're actually most of the time not flying back. So
Oh,
the pilot, who's the paramedic, is flying out. They're landing as close as possible to the emergency, getting out with their equipment, going to stabilize the patient. There's an ambulance that's on the way. It's going to show up whenever it shows up, right? We're not getting in the way of that. Once the ambulance shows up, our medic will be the one who's been on the scene the longest and will have the most knowledge of the patient, right? And they will likely go with the patient in the back of the ambulance to the hospital. They'll leave the aircraft at the scene. We have a second person on duty who helps the pilot do an abbreviated pre-flight inspection before the takeoff. And once the aircraft departs, they get in a retrieval truck, which is basically like a flatbed tow truck, and they go to the same place and they get there whenever they get there, right? And it's interesting because this sounds like, oh, this is such a big overhead and what have you, and it's actually not. From a cost perspective, it actually is very much not, especially when you factor in the cycle life on the batteries. It's way more economical to actually go out and pick the aircraft up, put it on the back of a flatbed truck, and drive it right back, uh, and get ready. The nice thing is you can be recharging, reconditioning the batteries on the drive back. You can get back to your ready state and be up and running and ready to save lives as quickly as possible in that way, right?
yeah.
And you've
And the
taken care of
retrieval
the
op-
patient.
and the
So it's a
retrieval
very,
operation does not require a pilot or anything like that, right?
that's correct. Yeah, yeah.
Yeah.
Now, oftentimes you'll go ahead and qualify that person as a pilot. That might be part of their training because they'll get familiar with the
Mm,
aircraft by being that sort of crew chief
mm,
on the
mm,
operation. But they don't need to be
mm. They
a
don't need to be.
pilot
Because
yet.
I was just going to ask you whether the Vertiport business is is widely discussed right now, and a lot of countries are looking into building this vertiports all over the city. And I wanted to ask you whether a vertiport would be a good place to operate from, especially if it's time critical.
Probably not. And the reason is that when this deployment happens, you don't want to have to talk to anyone, right? This is not, you don't want to wait for a clearance to depart. You want to be operating at a non-towered airport or somewhere that is remote from other flight ops. And again, the area where this can have the biggest impact is in rural areas, not cities, right? So vertiports are mostly going to be in cities, high population density areas. This saves the most lives in rural areas, right? Down where population density is low. That's where we can have the biggest impact. And that's a huge advantage from a safety perspective, from an operational perspective. We're not talking about trying to set up a vertiport in a city or anything like that, or doing operations in high population. Frankly, if you're in a high population density area, there's probably a frequent enough fire stations that your 911 response time is pretty good. And an eVTOL is not going to help, right? eVTOLs will definitely help in low population density rural areas. That's where the opportunity is. And this is very counterintuitive to like everybody who's used to, well, the economics are always better in high population density. No, not in this business model. It's very, very different. I mean, yes, you want higher population density, rural, low population density, but you want more people in your coverage area, obviously. But you don't want to be trying to conduct operations where you have tower controlled airspace at all. One of the reasons that I believe Jump Aero will be successful is that we are laser focused on where we can add value that is actually fundamentally better than any helicopter out there or anything else, right? There are no other aircraft that can get off the ground as fast as an eVTOL. And an eVTOL that's optimized for rapid deployment is just unstoppable. No other aircraft could depart that fast because with an eVTOL, fundamentally, you can go to full power with the flip of a switch and incur no maintenance penalty for doing that. Whereas any sort of aircraft that has a thermal engine, if you go to full fuel flow in an instant, you're going to thermally shock your engine. You're going to pay a price if you do that multiple times in terms of maintenance, in terms of seals rubbing, in terms of all sorts of thermally shocking your hot section. This is a mission where an electric aircraft is fundamentally better. And that is one of the reasons that I have confidence that this use case will succeed in the long run where others may fall short.
As a pilot in me, the pilot in me keeps asking that question since we started talking about it, is the flight profile and how the pilot will feel. You're building a full-scale version now. So, would that be piloted? Is that the plan? We're going to see how it feels for a pilot to take off standing.
Yeah. I mean, well, honestly, we have a pitch motion simulator in the other room where we've been iterating on this aspect of the human factors for the past few years, right? So yes, it is different. But it's actually a lot of fun. I mean, it's sort of like playing one of these really cool video games. Like the control is, it is designed to qualify for what the FAA has defined as simplified flight controls in the Notice of Proposed Rulemaking for the Mosaic rulemaking, the modernization of special airworthiness certificates. The SFC, the simplified flight controls, basically says, look, no combination of pilot inputs can drive the aircraft into an out of control state. So it's highly envelope protected, and that and in both modes of flight, both the hover mode and the cruise mode. So if you're a pilot, when you're standing up, you've got a hover stick that you push it forward and the aircraft tilts forward. You push it to the side, it tilts to the side. You twist it, and we do the little pirouette on the axis, and that's very similar to a number of other hovering eVTOLs. As the aircraft pitches forward, as it's accelerating, the flight control laws limit your envelope so that you can't do as aggressive maneuvers, because you do get to portions in the flight envelope where your control margins are not fundamentally not as large as they are when you're in pure hover or when you're in pure cruise. So you have to have more protections around that. That's why transition is such a big deal. So you get through that transitional flight phase, and now you're lying prone, and you've moved your hand from down by your side, your right hand, up to another stick, and you're basically lying prone with two inceptors in front of you, your axial velocity command lever and your stick, which is just like a stick when you're flying a normal fixed wing aircraft. So it's still protected.
And visibility for landing, if it's
That's one of the great things about this. So I don't know if you can see this, but there's a giant belly window right here. So on the front of the aircraft, your view, you have better visibility than any helicopter out there, because you don't have your legs in the way, you don't have an instrument panel in the way. Your head is basically right up against a piece of glass, or not glass, it's polycarb. And you have tremendous range of visibility with nothing in your way. So that allows you to do very steep approaches into unimproved landing zones and have better situational awareness of the area around where you're intending to put the aircraft down than any helicopter would. That's one of the big advantages of this novel tail sitter configuration. I do need to give a shout out to Mark Moore, who pioneered the modern tail sitter concept with his Puffin design out of NASA Langley in the 2009-2010 timeframe, because it does give you this fantastic visibility of your landing zone, and avoids all the tilting pods, and gives you very low frontal area when you're doing your high-speed dash. So it checks a lot of boxes for this mission. It's not something where you're going to carry a bunch of passengers with a thing where you're tilting over and lying on your stomach, but this is an aircraft that's operated by a trained professional. This is their job to do it, and it gives them a very unique capability. And when they fly this thing, they are literally flying like Superman.
What is the training would be like, and how much of assistance that pilot have in the from a technological point of view for aiding the flight in overall operations?
Yeah, so when the call comes in, the software basically identifies an array of landing zones near the emergency, right? And the pilot will select the one. Most of the time, they will likely select the one that's being recommended, but it's up to them. The flight is then planned, and can basically be executed like I don't want to call it autonomous, but I will say highly automated autopilot, right? Like a flight director type mission where you take off and the entire trajectory is basically flown and optimized. And then the aircraft, the autopilot basically gets you into stabilized hover 500 feet above and about 200 feet downwind of the recommended landing zone. So basically it gets you to a point, and now you're stopped here. And now you look out the window and say, okay, do I actually want to land there? And then it's up to the pilot if they decide, yes, I want to land there, or no, I'm going to go to alternate 1 or alternate 2 or what have you, now that they're looking out the window and can see what's available. So, but the automation basically will effectively get them to the decision point. And then from the decision point, they can hand fly it in. To put the aircraft in the orientation that they want to put it. Once they get it down, shut everything off, open the hatch, and grab the equipment that they need, and proceed to the location, the GPS coordinates of the emergency.
Is there an option for it to be remotely piloted? For example, if there is no need for a paramedic or a first responder to be there, but you are actually delivering critical cargo with a speed of, with a very high speed to the place.
Right. If there is a customer that will pay for that, we will do it. It's not
Right.
key to the business model that we are pursuing.
And speaking of customers, you've mentioned that it depends on the customer for the use case, for the location, and things like this. And in my head, I was thinking of guys like Doctors Without Borders, or an NGO somewhere in the village far away from first. From like a bigger town with the medical facilities. On your list of potential clients, who are these organizations? And does it come down to hospitals as well, private medical institutions, things like this?
Yeah, so we're talking to a wide array of different customers, from private ambulance
Mm-hmm.
operators like Falck, they're our launch
Mm-hmm.
customer. I mentioned them before, to government entities, county governments. Usually, emergency management is conducted at the county level. So there are so you would need to get licensed at the county level, and that sometimes cities will provide emergency response in rural areas. So it's very much county by county. It may be done differently, but and also the U.S. Air Force is one of our customers. They've given us a couple of contracts that we're actively working on. We're actually, one of those contracts is actually helping fund the construction of our first full scale prototype right now. So there's all different sizes of government entities that are involved as well. But most of the time, you're talking about county level or local governments that would be looking to deploy this. And we're actively working with one of those county governments in Calhoun County, Texas. We shared that we have an MOU with Calhoun County, and we are going to be applying together with them for grants to fund a demonstration of the technology in Calhoun County.
And outside of the US, do you have any
Yeah.
customers or potential customers that you're talking to? Because the way they operate is obviously very different, right? You have NHS in the UK, and you have other
Yes.
agencies and government agencies primarily in Europe.
Our first overseas customer is an outfit called Electro Ventures that actually is the parent to Electro Aero, which is a company that operates electric pipistrel aircraft today. Electro Aero makes charging systems for those aircraft, and they've got a company called Fly On E that actually operates the pipistrel aircraft. So they have quite a bit of practical hands-on electric aircraft experience. I've known Josh, their principal, for many years now. Another longtime entrepreneur in aviation, and he was very early on the electrification bandwagon. And so he and I have been talking for a long time, and he's going to be a key partner for us in the Asia Pacific area, particularly Australia, New Zealand, those sorts of areas where the rules are similar to what we have in the U.S., and the acceptance of light sport aircraft is fairly straightforward, and that way we can get deployment to happen in a very practical way in the early years of production.
Okay. That's fantastic. And I think this is where the application lies. The very specific use case, you get something done, make it simple, and there is a return both on investment and also improvement in the quality of life, because that's what technology is for, right? This is just absolutely fantastic. I'm really glad that we managed to speak with you, Carl, and really, really appreciate your time. And thank you so much, everyone who have joined us, who's been following and looking at the episodes. You make it possible, and because of you, we keep going, and we keep working on bringing you these different aspects of advanced air mobility, artificial intelligence, and the technology around it. So we'll see you next time. Bye-bye for now.